Eulerian paths and graph theory. Can we travel without walking the same road twice? A mathematical problem began with this question. It is the Königsberg Bridge problem. The Pregel River flowed through Königsberg, the capital of East Prussia in the 18th century. The river had 2 islands, and 7 bridges connected the islands and the mainland. People enjoyed asking whether it was possible to cross each of the 7 bridges exactly once and return to the starting point. In 1735, the mathematician Euler solved this problem in a surprisingly simple way. He did not use an actual map. Instead, he drew the land and islands as points and the bridges as lines. He called this drawing, made of points and lines, a graph. To answer the question, can every line be crossed exactly once? Euler focused on the number of lines connected to each point. For a point to be both the starting point and the ending point, each incoming path must pair with an outgoing path. Therefore, the number of lines connected to every point must be even. However, in the graph of Königsberg, every point had an odd number of connected lines. In the end, Euler proved that no path could cross every bridge exactly once and return to the starting point. What happens if there are only 2 odd vertices? In this case, it is possible to make a path that starts at one vertex and ends at the other. The path leaves the starting vertex one extra time and enters the ending vertex one extra time. Therefore, when there are exactly 2 odd vertices, a path that passes through every edge exactly once exists. A graph that passes through every edge exactly once and returns to the starting vertex is called a Eulerian circuit. If the starting vertex and the ending vertex are different, it is called a Eulerian path. Then how is a Hamiltonian path different? Here, the vertices matter, not the edges. In the 19th century, the mathematician Hamilton created the Icosian game, in which the player visits each of the 20 vertices of a regular dodecahedron exactly once and returns to the starting point. This game gave rise to the concept of the Hamiltonian circuit. A path that visits every vertex exactly once and returns to the starting point is called a Hamiltonian circuit. If the starting point and ending point are different, it is called a Hamiltonian path. The difference between these 2 concepts can be summed up in one sentence. A Eulerian path traverses each edge exactly once. A Hamiltonian path visits each vertex exactly once. This difference also appears in everyday life. Eulerian paths are important when every road must be covered, such as by street sweepers or snowplows. In contrast, Hamiltonian paths are more suitable when as many places as possible must be visited without repetition, such as in parcel delivery or sightseeing. The traveling salesperson problem is a classic example. An interesting point is that the 2 problems differ greatly in difficulty. We can easily determine whether a Eulerian path or Eulerian circuit exists by checking the number of edges connected to each vertex. However, once a graph becomes even slightly complex, it is not easy to tell whether a Hamiltonian path exists. That is why it remains one of the major problems that computer scientists actively study today. Graph theory now extends beyond mathematics into many fields. In computer science, it designs the internet and data structures, and navigation systems find the best routes. In sociology, it supports social network analysis that studies relationships between people. And in life science, it also helps researchers study the relationships between genes and proteins. When we use a map to find a route, analyze relationships on social media, or receive a package delivered along the most efficient route, graph theory is at work. Euler's idea of viewing the world through only points and lines still lives on in our daily lives, even after 300 years.